Okay, so let's see if we can find the cosine of 990. 990 is not on the unit circle, but I'm going to see if it's coterminal with an angle on the unit circle so that I can use those values to find it. So I'm going to start by subtracting 360. Gives me 0, 3, 630. 630 is still too big to be found on the unit circle, so I'm going to subtract 360 again. Okay, borrow from 5, 13, 7, 270. Okay, 270 is definitely on the unit circle. In fact, I know my coordinates there at 0 and -1. They want cosine on the unit circle. Cosine is the x value. So I know the cosine of 990 is just 0. Okay, and let's see about the cosecant of -31 pi over 6. Okay, now doing a little scratch work here on the side. Remember that I said we can think of that as -31 pi over 6, -31 times pi over 6, and we know pi over 6 is 30, so that's -31 times 30, if you want to do it this way. Okay, so -31 times 30, that's going to be -930. Okay, and so then -930, we can just come over here and start adding 360 till we get that to be positive. So if I do 360, it's negative. And you see, this is why Miss Weaver really likes the thinking of it as fractions, and I'll show you how to do that again in a second in case you want to try that way. But -930 plus 360 is -480. Sorry, I was like, that doesn't seem right. Let's go try that again. It's 570, -570. Okay, it's still too big, so I'm going to add 360 again. And that gives me -210. It's still negative, and we aren't crazy about negative numbers, so I'll add 360 again. And that's 150, and it's finally positive. So -31 pi over 6 is coterminal with 150. So where is 150 on the unit circle? Well, it's right over here, 30 degrees away from pi. So I know those coordinates are √3/2 and 1/2. And I know the x-coordinate's negative in second quadrant. Okay, so -31 pi over 6 is coterminal with 150. If you wanted to do it the other way, where you draw it out thinking of the fraction. So the question to ask yourself is, what does a whole pi look like with the denominator of whatever this denominator is? So what does a whole pi look like with a denominator of 6? It looks like 6 pi over 6. So if I want to count it out going negative, I'm going to go -6 pi over 6, -12 pi over 6, -18 pi over 6, -24 pi over 6, -31 pi over 6. Sorry. -30 pi over 6, and one more pi over 6 will make it -31 pi over 6. So that still makes it coterminal with 150, just pi over 6 above that x-axis, um, negative x-axis. And so that tells us where it's at, so then we can then use those trig values to find it. Okay, so what do we want? We want cosecant, which is the reciprocal of sine. So sine is the y value. So I'm going to grab the sine value and I'm going to flip it. So instead of 1/2, we'll do the reciprocal, 2/1. 2/1 is just 2. So the cosecant of -31 pi over 6 is just 2. Okay, that was a lot of scratch work. I'm going to clear it up so that we have room to do some more. You can rewind the video if you want to watch that part again. Just counting -6, -12, -18, -24, -30, and one more to make -31 pi over 6. So we're counting by sixes, counting by 6 pi over 6 to find the fraction. Or you can just do the multiplying like we did on the first example. All right, so let's try -5 pi over 6. This one I'm going to go ahead and just let us practice finding negative angles. Nobody's crazy about doing negative angles, but it's you count the same way as you would forward, but you're going backwards. So I know that a whole pi would be 6 pi over 6. So if I'm going backward, I'm not going backward a whole pi over 6. I'm going back -5 pi over 6. So it's 1 pi over 6 away from a negative whole pi. So we're there, coterminal with 7 pi over 6 in the third quadrant. I know my coordinates there are going to be root 3 over 2 and 1/2, but everything's negative in third quadrant. The x and y are both negative. We want the cosecant now. Cosecant is the reciprocal of sine. So if I can find the sine value, where is the sine value, x or y? Remember, it's our xy, our cosine theta, sine theta. I like to say it, I like to write it, I like to have it on every page just to look real quick and remind myself. So I want cosecant. Cosecant's the reciprocal of sine. So I'm going to grab the sine value, which is the y value, and I'm going to flip it. So it's negative 2 over 1, which simplifies to negative 2. Reciprocals are nice and fast. If you can find the original, you just do the flip of the fraction. Cosine of negative 17 pi over 3, which way do you want to do it? Miss Weaver's going to show you first again. So I think about, what does a whole pi look like with a denominator of 3? It looks like 3 pi over 3. Can you count by 3 pi over 3s? And can you count backwards? So let's try. So that'd be negative 3 pi over 3, negative 6 pi over 3, negative 9 pi over 3, negative 12 pi over 3, negative 15 pi over 3, and I've got to go 2 more pi over 3. So it's coterminal with pi over 3, where I know my coordinates are 1/2 and root 3 over 2. Okay, so you can do it visually, or let's go ahead and try it with the numbers because a lot of people think that's easier. So it's negative 17 times pi over 3. I know that pi over 3 is just 60, so that's negative 17 times 60 is one way to do this. Okay, so 17 times 60 will be 1020, so it's negative 1020. Now that we know what it is, coterminal within degrees, we can start adding 360 to that. And so if I do negative 1020, and I add 360, that gives me negative 660. So I want to add 360 again because we're trying to get it to be the lowest positive coterminal angle. That's what we're looking for. So I'm going to add 360 again. That'll be negative 300, still negative. So I'm going to add 360 again. And I get positive 60. And that's what we said. It's coterminal with positive 60 degrees. So we know those are the x and the y coordinates there that we can use. So you can either do it from the picture or numerically, and you'll get the same answer. And you also could have just done a straight unit conversion, but I just think this multiplying by 60 is faster than doing the radian to degree conversion. So choose your method and let's get going. All right, we know what the coordinates are. We just want the cosine. So now that we know where we are in the unit circle, this is going to be fast and easy. Cosine is my x or my y coordinate. It's my x coordinate, so I grab it and we're done. Coterminal angles have the same trig values. The cosine of negative 17 pi over 3 is the same as the cosine of pi over 3, which is 1/2. Sine of 29 pi over 6. All right, are you feeling up to trying Miss Weaver's way without all the numbers? I'm going to let you choose your way. I'm just going to do it one way. So I'm going to do it by counting by, what does a whole pi look like over a denominator of 6? It looks like 6 pi over 6. So are we ready to count by 6s, by 6 pi over 6? Let's try. Okay, so we're going to go 6 pi over 6, 12 pi over 6, 18 pi over 6, 24 pi over 6. And we've got to go 5 more pi over 6 to make 29 pi over 6. Okay, so count that again. So we go 6, 12, 18, 24, and we still have to go 5 more pi over 6 to get to 29 pi over 6. So it's going to be coterminal with 5 pi over 6. So it's going to have the same trig values as 5 pi over 6. At 5 pi over 6, we know that the coordinates are root 3 over 2 and 1/2, but we're in quadrant 2, so the x is negative. So we want the sine value for 29 pi over 6, so it's going to be the same as the sine value for 5 pi over 6 because they're coterminal angles, and coterminal angles have the same trig values. So it's going to be the y value So it's going to be 1/2. Okay, let's try secant of 945. Okay, so 945 is already in degrees, so we might as well just start subtracting 360 from it. So if we try 945, I'm going to start by subtracting 720 because 720 is 2 rotations. I know it's at least that big. So that's going to be 5 to 225. So 945 is coterminal with 225, which I know that's right in the middle of the third quadrant. Both coordinates I know are negative root 2 over 2 and root 2 over 2 there. That didn't when it's the ones that end in 5, they're our easy coordinates. Now secant is the reciprocal of cosine. So if I can find the cosine value, I can just do the flip of the fraction to get the secant value. So what's the cosine value at 945? Well, it's the same as the cosine value at 225, so it's the x coordinate there. So the cosine would be negative root 2 over 2, but we want the secant, so we're going to do the reciprocal or the flip of that fraction. So it's going to be 2 over negative root 2. So we've got to rationalize that denominator. So I'm going to multiply by root 2 over root 2. That gives me, I'm going to move that negative to the numerator so I don't lose track of it. So that's negative 2 over root 2. Root 2 times root 2 is 2. Are we finished? No, because the 2 and the 2 cancel. So it leaves me negative root 2, final answer. Okay, cosine of negative 11 pi over 2, I'm going to count that by 2's. So I know that I can go, oh, we're going negative, so we'll go the other direction. So negative pi over 2, negative 2 pi over 2, negative 3 pi over 2, negative 4 pi over 2, negative 5 pi over 2, negative 6 pi over 2, negative 7 pi over 2, negative 8 pi over 2, negative 9 pi over 2, negative 10 pi over 2, negative 11 pi over 2. We did it. We did it. We made it. Okay, that was a very negative angle there. So negative 11 pi over 2 is coterminal with pi over 2. I know there my coordinates are 0, 1. They want the cosine, which is the x-coordinate, so that's 0. So the cosine of negative 11 pi over 2 is just 0. I actually do like the drawing it out. To me, that's the fastest way to do it. I counted by single pi over 2's that time because I knew each quadrant was pi over 2. So I said negative pi over 2, negative 2 pi over 2, negative 3 pi over 2, negative 4 pi over 2, negative 5 pi over 2, negative 6 pi over 2, negative 7 pi over 2, negative 8 pi over 2, negative 9 pi over 2, negative 10 pi over 2, negative 11 pi over 2 is what we did there. But I could have thought of a whole pi looking like 2 pi over 2, and that might have made it a little faster to count. Okay, it would have been negative 2 pi over 2. Let's see if I can do that with a fatter pen to help you see. It would have been negative 2 pi over 2, negative 4 pi over 2, negative 6 pi over 2, negative 8 pi over 2, negative 10 pi over 2, and one more pi over 2 to get there. Okay, so if you can do it that way, that's my favorite way to do it. If not, convert it to numerically and find it there. Sine of negative 2 pi, last one. Negative 2 pi is coterminal with 0. Negative 2 pi is right there. I know my coordinates there are 1, 0. They want the sign, which is the y value, so that's just 0. Good luck practicing your exact values.